Hello, in this video I'm going to be working through the chapter 7 through 8 practice test. Okay, first question has me writing a system of equations as an augmented matrix. So let me do that first. Just going to take the coefficients and put it in a matrix form. Negative 5, 3, 6, 4, negative 3, 1, 5, negative 5, negative 4, 2, 1, 13. And usually we would also put a line here, but I'm quite lazy, so I'm not going to do that. Okay, looks like I copied that correct. It's always very good to double check that first step because it's one of the most important ones. You don't want to mess up there. All right, and so then now I'm going to go in the process of trying to convert this to reduced row echelon form. So that means I'm going to try to get rid of this first, then this, and then this, and then this, and this, and then this. Okay, in that order. Trying to convert them to 0 by row operations. Okay, so firstly, I'm going to try and get rid of that negative 3. Looks like the best way to do that would be to do 3r1 minus 5r2. Okay, the reason is because that is going to give me, that is going to be negative 15 here minus, sorry, what? Yeah, that's correct. Negative 15 minus 15. Sorry, negative 15 minus negative 15, which is 0. So that'll give me a 0 there in that first position. And then similarly, on the very third row, I'm going to do 4r1 minus 5r3. That is going to give me negative 20 minus negative 20. Okay, so I'm kind of doing it in an abbreviated way so that I don't have to write the matrix as many times. But you could also do it the longer way, just by doing the multiplications more explicitly. So you could just, for example, multiply the top by 3, this by negative 5, and then add afterwards. That would give you the same answer, but you would just have to maybe write it twice as much. So do that if you're not comfortable with this shorter method, which can introduce some more mistakes if you are not as proficient with keeping that many numbers in your mind. All right, so the top is going to remain the same, minus 5, 3, 6, 4. But the second row is going to become 0, and then 3 times 3 minus 5 times 1, so it's 9 minus 4, and then 18 minus 25, negative 7, and then 12 minus negative 25, so it's 37, I think. Yep, even I'm having trouble with this. Yeah, it should be 12 minus 25, 37. Okay. Then the bottom row becomes 0. Then 12 minus 10, so that's 2. 12 minus 10 is 2. Then 24 minus 5 is 19. And then 16 minus 65 is negative 49. I hope. 16 minus 65. Yeah, really struggling with this arithmetic. It's not easy. 16 minus 25. Yeah. Negative 49. Okay, then next I'm going to try to get rid of this 2. Thankfully that's a little easier. All right, so I'm going to do, I have to cancel with the second row, right? If I had tried to cancel with the first row, then that would have introduced a number into this position here. But the second row is good because we both have zeros here, so they're not going to affect each other. So replace the third row with r2 minus 2r3. Get negative 5, 3, 6, 4, 0, 4, minus 7, 37, and 0, 0, negative 7 minus 38, negative 45. And then 37 plus 98 is 135. All right, 37 plus 98, 35 plus 100, 135. Okay, very good. And then my next step, I can probably simplify the third row, because 45, that leaves me with, sorry, 29. I can divide both sides by 5. Sorry, both 45 and 135 by 5, which gives me negative 5, 3, 6, 4, 0, 4, minus 7, 37, and actually 45, 135 is just 45 times 3, right? So that's 0, 0, 1, minus 3. If I divide both by negative 45. Okay? So next step is to get rid of those top right elements. So I'm going to try to get rid of those two first. How do I do that? I'm going to replace the first row by R1 minus 6R3. And the second row I'm going to replace by R2 plus 7R3. That's going to give me zeros in those 6 and minus 7 positions. Okay. So the first row is going to become negative 5, 3, 0, because that's 6 minus 6, and then 4 plus 18, so 22. And the second row becomes 0, 4, and minus 7 plus 7 is 0, good. And then 37 minus 21, so that's 16, I think. And the bottom stays the same, so 0, 0, 1 minus 3. Okay, so I can simplify the second row now. That's just 0, 1, 0, 4. Okay, and so finally my last step is to get rid of this 3 here. And so I can just change the top to R1 minus 3R2. And that leaves me with negative 5, use red, negative 5, 0, 0, 22 minus 12, it's 10. Okay, and I'm almost in reduced row echelon form, just need to get all those to ones, all the diagonals. And so that just becomes 1, 0, 0, minus 2, dividing the top by negative 5, 0, 1, 0, 4, 0, 0, 1, minus 3. So now I can just read off my answer. XYZ is negative 2, 4, negative 3. Okay, let me check that using my computer. Don't want to be giving you the wrong answers here. Good, looks good, did it right. Next question. Okay, here we have a simple matrix addition problem. So that's very easy. We just multiply A by 3 and then subtract B. So maybe to make this a little more explicit, I can multiply A by 3. That will also reduce some errors, right? So 9, 3, 6, minus 6, 12, minus 3. And then I just subtract B. So that means 3A minus B is going to be 9 minus 0, 9. 3 minus 2, 1. Then I can do the rest. Okay, minus 6 minus negative 3 is negative 3. 10, then negative 2. Okay, so that's going to be my answer. Hopefully that's right. Let me double check. Oh, sorry. Gosh. 12 minus 1 is 11. Okay. That's a terrifying mistake. All right, here we're going to do some matrix multiplications. And so it's very important first to verify that the matrices can be multiplied. So this is a 2 by 2 times a 2 by 2, so that's good. And so I'm going to multiply them by putting the first one on the left side, kind of the second method that I showed you guys in class. So the first matrix on the left side, and the second one goes to the top. Okay, and then I'm going to multiply element by element based on which row and column lines up with that. So the first element is going to be 8 plus 1, 2 times 4 plus 1 plus 1, plus 1 times 1. So that's 8 plus 1, which is 9. And then I have 10 minus 1, so it's also 9. And then 0 plus 3, and 0 minus 3. Okay, so that's going to be my answer here. 9, 9, 3 minus 3. Okay, so this matrix, on the other hand, is a 3 by 2 times a 3 by 2. And so these numbers in the middle here do not match. So that means this is undefined, not allowed. Okay, you could also try putting it in this format here, and you would quickly see that the multiplication is not possible. Next question is a 2 by 3 times 3 by 2, so that's all good. So I'm going to put the first matrix on the left. The second matrix on the top. I'm going to end up with a 2 by 2 matrix. And what are the elements? I have 3 plus 0 minus 25. It's minus 22. And then I have negative 1 minus 8 plus 10. So it's negative 1 minus 8 minus 9 plus 10. So it's minus 1. And then I have minus 3 plus 0 plus 0. Sorry, minus 9 plus 0 plus 0. So that's minus 9. And then positive 3 plus 16. So it's 19. Okay. So that'll be my answer there. Now, if you want partial credit, in the case of making some arithmetic mistakes, you should also try to show some work. So you should write 1 times 3 plus minus 2 times 0 plus 5 times minus 5 is equal to negative 22. So I would show that work on the side if you want any form of partial credit. Otherwise, I'm going to just take off points for every single number that you miss. Okay. Let's keep going. Actually, let me quickly check to make sure these are all correct. Can never be too careful, right? Oh dear, made a mistake. This should be negative 1 minus 8 plus 10. That's positive 1. Oh my gosh. Okay, negative 22, 1, negative 9, 19. Okay, really sorry about that. Negative 1 minus 8 plus 10. Yeah, that's 1. Okay, let's keep going. So here I need to find some inverse matrices. So I'm going to remember my formula, right? The inverse of A, B, C, D is 1 over the determinant, so AD minus BC, and then D and A swap places, and B and C become negative. Okay, so that's my formula. And so that means this is going to be equal to 1 over the determinant, so that's minus 2 minus 6, which is negative 8. So 1 over negative 8. 1 minus 2 minus 6. 1 over negative 8. And then D and A switch places, so negative 2 goes to the top left and 1 goes to the bottom right. And then B and C become negative. So negative 3 and negative 2. Okay? And so you could leave it like that. I'd probably accept that. But I'm just going to simplify this. That's going to be 1/4, 3/8, 1/4, negative 1/8. All right, that's my answer. Let me check that. I'm really just going to check every answer from now on. Already made 2 mistakes. It's horrifying. Okay, looks good. Going to do the same thing here, but I'm going to notice something interesting, which is that the determinant is actually 0, right? Because the determinant AD minus BC is 6 minus 6. And so I don't even need to do the other matrix here. I can just really write undefined immediately. Okay, the inverse does not exist. Even though it's a square matrix, it doesn't exist because the determinant's equals to 0. Next question has me calculating an inverse matrix using Gauss-Jordan elimination. So as you might recall, the process for doing this is first writing A next to I on the right side, and then doing Gauss-Jordan elimination until you have I on the left side, and you'll end up with the inverse of A on the right side. Okay, so I'm going to write 7, 2, 1, so the matrix on the left side, and then the identity matrix on the right side, so 1, 0, 0, 0, 1, 0, 0, 0, 1. And then I'm going to do row operations until the left side is the identity matrix. That's Gauss-Jordan elimination. So I'm going to change the third row to 3R1 plus 7R3. That's going to make this negative 3 into a 0. That's 21 minus 21. Good. Okay, so I have 6 plus 28, 34. And then 3 minus 14, just negative 11. And then got 3, 0, 7. Okay, next step is to get rid of the 34 there. So that means that I'm going to change the bottom row to 34 R2 minus 3 R3. Okay, that leaves me with 7, 2, 1, 1, 0, 0. Then 0, 0. Okay, and then minus 34 plus 33. That is negative 1, right? Minus 34 plus 33, negative 1. Good. And then 0 minus 9, it's negative 9. And then 34 here, it's 34 minus 0. And then 0 minus 21, so negative 21. Okay. Then next step, I need to get rid of these 1 and this negative 1 here. So I'm going to do that by combining with the third row, because that has a lot of zeros already. So I'm going to change the first row to R1 plus R3. And the second one, I'm going to do R2 minus R3. So the first row will become 7, 2, 0, 1 minus 1. 1 plus negative 9, negative 8. 34, negative 21. Second row will become R2 minus R3. So that's 0, 3, 0. 0 minus negative 9, positive 9. 1 minus 34, negative 33. 0 minus negative 21, positive 21. Then the bottom row, I'm also going to flip the sign. So let me write that, because I want that negative 1 to become a positive 1 if I want it to be the identity matrix. So 0, 0, 1, 9, negative 34, positive 21. All right, final step is to get rid of that 2 on the top. Maybe firstly, just to make this math a little simpler, I'm going to divide the second row by 3. So let's do that. R2 over 3. So I have 7, 2, 0, negative 8, 34, negative 21. And then 0, 1, 0, 3, negative 11, 7. 0, 0, 1, 9, negative 34, 21. And then I'm going to replace the top row by R1 minus 2R2. That'll cancel out that 2 on the top there. So I'm left with 7, 2 minus 2, 0, 0. Negative 8 minus 6 is negative 14. 34 minus negative 22 is 56. Then negative 21 minus 14 is negative 35. I think. Sorry, that should have been in red. And the final step is just to divide the first row by 7, which leaves me with 1, 0, 0, minus 2, 8, minus 5, 0, 1, 0, 3, negative 11, 7, 0, 0, 1, 9, negative 34, 21. And so that means my inverse matrix is simply what I have on the right side. My answer is negative 2, 8, negative 5, 3, negative 11, 7, 9, negative 34, 21. I can check my answer using a computer here. It looks like that is correct. So we'll move on. Question 6 has me evaluating a bunch of determinants. Okay, and that's my last page. Great. So the first one is a 2 by 2 determinant. So the formula is just AD minus BC, right? The determinant of ABCD, the 2 by 2 matrix, is just AD minus BC. Easy to remember. So that means this is 10 minus negative 7, which is 17. The second one is negative 1 times negative 6 is positive 6. 6 minus negative 10 is 16. Then finally, not finally, here we have a 3 by 3 determinant. You could do this in different ways because you're allowed to expand via cofactors with any row or column you want. I'm going to start with doing the first row because that's pretty conventional, and then maybe afterwards we'll try the first column because that's that has more zeros, so it's easier, right? Let's do the first row first. So that's going to be
This is the junior high 5-minute warning bell. Please head to class.
So the row 1 expansion is going to give me negative 1 times the determinant of 4, 2, 3, 7 minus negative 5, right? It's the minus because if I drew the grid of pluses and minuses, the top left is always a plus, which means that this negative 5 has to change sign, and the 3 doesn't change sign. Okay, so that's why it's a minus there. I'll just leave this. Okay, so minus negative 5 times the determinant of 0 to negative 1, 7, plus the determinant of 3, plus 3 times the determinant of 0, 4, negative 1, 3. And so that leaves me with negative 1 times 28 minus 6, which is 22, plus 5 times 0 minus negative 2, which is positive 2, plus 3 times 0 minus negative 4, which is positive 4. So in the end, I have 0, interestingly. I'm pretty sure I chose those numbers at random, so pretty surprising I got 0. Okay, let's try column expansion. So let's do this using column 1. The motivation for that is because column 1 has a 0. So that allows us to compute one less determinant, which is something we always like. And so if we did that, we would have negative 1 times the determinant of 4, 2, 3, 7 again. Now minus 0 plus negative 1 times the determinant of negative 5, 3, 4, 2. So that gives us negative 1 times 28 minus 6, again, 22, minus 0, minus negative 10 minus 22. It's negative 22. Right? Yeah. So that's negative 22 plus 22, which is 0. All right. Let me check this using my computer. Looks good. 0. Okay, final question. I have a 4 by 4 determinant. Looks daunting, but if I choose the rows carefully, this is not hard at all. So let me do this using the first row. Okay, you could have done pretty much any row or any column. It would have given the same amount of works, but I'm just going to choose the first row. So that means I have, all right, this is going to be plus and minus here. So it's going to be 1 times the determinant of 4, 0, 0, 0, 2, 1, 0, 3, 4, minus 5 times the determinant of 3, 0, 0, 0, 2, 1, 0, 3, 4. And so now that is just going to be equal to, right, for both of these I can expand via the first row or the first column. Both of them would give the same process. But I'm choosing those rows or columns because they have the most zeros, so I have to compute the least amount of determinants. So I'm left with, all right, negative 1 times that determinant is just going to be 4 times the determinant of 2, 1, 3, 4, minus 5 times 3 times the determinant of 2, 1, 3, 4. It's very important to make sure you're not dropping any factors. And then the final answer is 4 times 8 minus 3, 80 minus BC, that's 5, minus 15 times, once again, 8 minus 3, that's 15 times 5. So in the end, I have 20 minus 75, which is negative 55. All right, let me check my answer. Okay, looks good. So you'll notice that this is also equal to the determinant of 1, 5, 3, 4 times the determinant of 2, 1, 3, 4, which is just 4 minus 15, which is negative 11, times 8 minus 3, which is 5, is negative 55. This is what we call a block diagonal matrix. So if you took linear algebra, later in life, you'll learn that this is a faster way of doing it. But that concludes this video. I hope it was helpful, and good luck on the test.